All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So now, what is average velocity and average velocity and instantaneous velocity? See, suppose if I consider that this is the actual distance. Okay, so we are traveling in this manner, and what will be my displacement? It's going to be the shortest distance. Okay, which is nothing but straight line which is connecting these 2 points. Okay, let it be A, let it be B. Okay, so AB vector will be nothing but OB vector minus OA vector. OB vector is nothing but position vector, that is final position vector, minus initial position vector. Let us take it as S2 minus S1. Okay, so this will give me my displacement, right? So the distance means I need to count the total distance which we are covering. Displacement means simply if I want to find out displacement from A to B, displacement of AB, then simply it is S2 vector, that is position vector at final minus position vector at initial. So if I talk about average velocity, it is simply final position vector, or in first I will define it, total displacement by total time taken. Total displacement is nothing but final position vector minus initial position vector totally divided by time taken to cover the total distance. Okay, that's it. So this will be my average velocity. Okay, now coming to instantaneous velocity. Instantaneous velocity means what? Again, we are going to find out at some particular point. Okay, that is at that instant. So how to do? Very simple. Delta t has to be tending to 0. Okay, for like if I take a delta t like this, it has to be tending to 0. Okay, very small point. Now, if delta t tending to 0, what is mean by delta t tending to 0? The difference between the time, okay, between one point to another point, that will be very small. If the distance is very small, it's very obvious. We can easily identify that if the distance is very small, both this distance, that is time, okay, delta t is very small. Both this displacement curve, okay, both this displacement curve and distance curve, both will be a straight line only, right? Let me show you something. Listen carefully. Yeah. So let this be the distance curve. Okay, let this be the distance curve. If I'm taking very small, okay, I'm taking a very small distance delta t. If delta t is going to become very small, if delta t is very small, obviously delta s is also going to be tending to 0. That is very true, right? If time taken, if the distance between the time was small, then the distance will also be small. So if delta t is small, then delta s will also be very small. If the delta s was more, then there will be some difference between displacement and distance. But if delta s was very small, then it's going to become almost a straight line, right? Even the curve will also become a straight line. This is very common thing which you should know. Even if the distance becoming very small, then the curve will also become a straight line, almost straight line. Even though if you take a curve, I will show you again, even though if you take a curve, if the distance was very small, okay, I'm taking very small distance, then it will look like a straight line only. Okay, so if I take small distance, if delta t is tending to 0, delta s will also be tending to 0. So if delta is very small, then displacement and distance will be almost same, because displacement will also be straight line, Since delta s is small, distance is also a straight line. So displacement is approximately equal to distance. So from this, what we are getting? Very obvious, average speed and average velocity will be, sorry, instantaneous speed and instantaneous velocity will be same. Okay, so instantaneous velocity or instantaneous speed, since displacement and distance are almost same. Why they are same? The distance was very small. Why distance are very small? Because delta t has to be small for finding out instantaneous velocity. If I want to find out at that instant, delta t has to be very small. If delta t is very small, then distance is also small. If time taken was very small, then the distance covered will also be very small. If this is small, then curve and straight line both will be same, both will be similar. So displacement is also a straight line, distance is also a straight line, so both will be approximately same. So instantaneous velocity will also look similar way. Okay, limit, what is that? Limit delta t tending to 0, delta s by delta t, which is nothing but ds by dt. See, this s can be s vector or s, because since I am finding instantaneous velocity, s and s vector will be same only. For simplicity, let me just mark it as s vector. Okay. So instantaneous velocity and instantaneous speed both will be same, but average velocity and average speed will be different. Average speed is total distance by total time. Average velocity is total displacement by total time. If I take instantaneous speed or instantaneous velocity, simply differentiate s with respect to time. If you want to find at some particular time t is equal to 3 seconds or t is equal to 4 seconds, you substitute that time, you will be getting it. Okay, we will do some examples, you will understand it more clearly. So let us discuss few problems related to average velocity, average speed, and an instantaneous velocity and instantaneous speed. So I taken one question here, we could read it. It is 260 kilometers from Patna to Ranchi by air and 320 kilometers by road. Okay, an airplane takes 30 minutes to go from Patna to Ranchi, whereas deluxe bus takes 8 hours. Okay, find the average speed of the bus, average speed of the plane, average velocity of the plane, average velocity of the bus. So first we will start, first we will extract the given data. Okay, so they said that 260 kilometer from Patna to Ranchi by air, right? So let us keep this is Patna and let this be Ranchi. Okay, so by air means that is going to be the shortest route of all, right? That we know very clearly. By air in the sense shortest route, right? Obviously that is what it is meant to be, shortest route, right? So shortest route, so we will just mark it as a straight line. Okay, so yeah, so shortest route. Okay, so this distance was how much? 260 kilometers. Okay, and this is going to be by air, which means I am traveling in plane. But if I travel in what is that, in bus, okay, so it's going to take different routes, so it's going to take a different turns and all those things, and it covers a distance of 320 kilometers, and this is by road. Okay, right, so now let us start discussing the problem. First, average speed of the bus. Okay, so generally average speed is what? Average speed is nothing but total distance by total time. Am I right? Total distance by total time. Okay, now, first and foremost thing is they are asking about what? They are asking about bus, right? What is the total distance bus has traveled? 320 kilometers. Very, very easy one. And total time it has taken was 8 hours, right? So 320 by 8, which is 40, yeah, which is 40 kilometer per hour. Okay, am I right? Very straightforward first question. And what about the second question? We'll move for the second question. Average speed, again they are asking about average speed only, but this time it is not for bus, it is for plane. Okay, so for plane, what is the actual distance? Okay, again it is also total distance by total time only. Now what is the actual distance plane has traveled? plane has traveled 260 kilometer only. Okay, so in air it has traveled 260 kilometer only. So the actual total distance was 260, and in what time it has traveled? In 30 minutes. 30 minutes means half an hour, right? So 1 by 2 hour, which is nothing but 520 kilometers per hour. Okay, right. So what about the third one? Third one, average. Let me erase it so that I will have some space or something like that. So third one was average velocity of the plane. Okay, so now they are asking average velocity of the plane. We know that for a plane, see, simply average velocity means what? Displacement, right? Average velocity means what? Displacement by time taken. What is the displacement here? Here, out of this two routes which they given, 260 and 320, 260 is the shortest one. So shortest distance was 260, and the time taken for plane to cover that distance was half an hour. So this is also 520 kilometer per hour. So first question we got 40 kilometer per hour. Second question we got 520 kilometer per hour, and third also we got 520 only. Why it is 520? Because for plane, okay, for plane both displacement and distance are same only. The shortest distance is also 260 kilometer. The distance which it traveled is also 260 kilometer. Okay, and now finally average velocity of average velocity. Let me take it out. Let me take it the fourth one. Average velocity of bus, okay, in this case, that is going to be equal to the total displacement. Again, displacement by time, and displacement for bus is what? See, actual distance the bus has traveled was 320 kilometers, but the shortest distance was 260. So displacement is 260, and how much time bus has taken to travel? Bus has taken to travel 8 hours. So 260 by 8. Okay, so you have to understand this point very clearly. This is something which is not going to be straightforward. Okay, average velocity of the bus. Total displacement by total time taken. Total displacement is 260. Why 260? Because 260 is the shortest one, and divided by 8 hours, because 8 hours is the time taken by this bus, okay, for traveling. So 260 by 8, that is going to be 32.5 kilometer per hour. Okay. In 1 second, a particle goes from point A to point B, moving in a semicircle. As you could see here, in a semicircular way, the particle is moving. Okay. The magnitude of average velocity is dash. See, for finding out average velocity, we need to use the total displacement by total time, right? So for moving from A to B, the total distance covered was this complete perimeter. But displacement will be just 2 meters, because 2 meters is the shortest distance. So shortest distance, that is displacement by total time taken, they clearly given that in 1 second. Okay, so 1 second. So 2 meter per second will be our correct answer, which is option C. Okay. A person traveling on a straight line moves with a uniform velocity v1 for a distance x. Okay, so they clearly mentioned that the person is traveling in a straight line. Okay, with a uniform velocity, velocity is not going to vary. Okay, so straight line. Okay, for a distance x. Okay, for a distance x, the person is moving with a velocity v1. Okay, and with the uniform velocity v2 for the next equal distance, which means again for the next x distance. Okay, again for the next equal x distance, this has to be a straight line. Yeah, again for the next equal x distance, he is traveling with a velocity v2. Let me take, this is a, this is b, this is c. Okay, now what is the next thing? The average velocity is given by, they are asking average velocity. So first of all, average velocity is what? Total distance, in this case velocity, right? So it is total displacement, okay, by total time taken. Okay, what is total displacement for this case? displacement is nothing but the shortest distance, right, from A to C. See, already it is a straight line. So already it is a straight line. So obviously it's going to be the shortest distance. There is no other possibility for another shortest distance. So since it is a straight line, 2x will be our total distance. That 2x will be our shortest distance also, which is nothing but x plus x. That is 2x will be our total displacement also. Okay, now the question is how to identify or how to find out the time taken. Simple question, in fact. For a distance x, okay, for a distance x, the person has traveled with the velocity v1. So what will be my time taken? Time taken for covering this distance x initially. So t1 will be simply, generally what is velocity? Okay, what is velocity? Distance by time, right? So if I want to find out v1, it's going to be t1. So simply t1 will be x by v1. And similarly, v2 is nothing but, again, for covering this distance x, the person is traveling with the velocity v2. So v2 will be x by t2, which implies t2 is going to be x by v2. A simple logic, now substitute this here. So average velocity will be, here it will become total time. Total time is what? T1 plus T2, right? Total time is T1 plus T2. Time taken to cover this distance and also time taken to cover this distance. So which is going to be x by v1 plus x by v2. I can take x commonly. Okay, I can take x commonly. Let me write it here. This will become 2x. In the denominator, I will take x commonly. So it becomes 1 by v1 plus 1 by v2. So these two x's will get cancelled. So average velocity, okay, so that I will just take it as v, because they also taken it as v, right? So average velocity v is equal to this. I can do some rearrangement. What I can do, I can bring this 1 by v1 plus 1 by v2 that side, and this v, that is average velocity, to this side. So if I do that, it will become 2 by v. Okay, I'm just bringing this v to the another side, and I'm bringing this 1 by v1 plus 1 by v2 to another side. So it will become 2 by v, which is equal to 1 by v1 plus 1 by v2. Okay, so this is our correct answer, which is option C. So let us discuss about what is mean by acceleration. Again, acceleration is also something which most of you already know that. I'm just going to recollect it faster. Okay, so velocity, how fast the velocity is changing. That is what acceleration is going to give us. Simply, you can take an example of, what is that? You can take an example of a car or a bike. Initially, if it is moving at 40 meter per second, and after some 10 seconds, it is increased to 50. After some, or else we will talk in terms of kilometer per hour. Okay, 40 kilometer per hour. After some 10 seconds, it increased to 50. Then after some 10 minutes, it is increased to 70 or 80. So that change in the velocity, okay, how fast the velocity is changing with respect to time. Okay, that is what acceleration is indicating. Simply rate of change of velocity. Okay, so what is that? How fast the velocity is changing. Okay, and again we have two types of acceleration. One is average acceleration, okay, which is nothing but what? Simple, whatever we learned until now, that is total change in the velocity. Okay, total change in the velocity. Okay, total change in velocity by total time taken. Okay, total time taken, which is going to be simply final velocity minus initial velocity by total time taken. If you want, you can write it as t2 minus t1. Okay, and what about instantaneous acceleration? Again, instantaneous acceleration, this is also the same logic whatever we discussed earlier. At that instant, okay, at some particular instant, what is going to be the change in the velocity? So delta v by delta t, when delta t tending to 0. Okay, when delta t was very small, that is at some instant. Okay, so instantaneous means what? At a particular point, right? So delta t tending to 0. So when delta t tending to 0, the change in velocity by change in time, that is delta v by delta t, will give me acceleration. So that I can write it as dv by dt. Okay, See, one more point, we already know that v, that is instantaneous velocity, is nothing but change in displacement with respect to time, right? If you want, you can mark it as a vector, okay, since it is a displacement, change in displacement with respect to time. So if I substitute this here, okay, what will happen to my instantaneous acceleration? See, this instantaneous acceleration, sometimes they will be calling it as linear acceleration also, because there is one more classification, angular acceleration, that we will discuss separately in circular motions, okay? So yeah, so what I was saying, so a will be equal to d by dt of, in place of v I can substitute the rate of change of displacement, right? So that will become d square s by dt square. So I can write acceleration either in terms of velocity and time, or acceleration in terms of displacement and time, and this is linear acceleration, okay? So now let me give you one equation which is going to be very useful when we are solving problems, okay? So we know that velocity is rate of change of displacement, velocity or linear velocity or instantaneous velocity, different names, but majorly we will use the name as velocity, okay? And similarly, acceleration, linear acceleration, or what is that, instantaneous acceleration, and we can use any words, and majorly I will be using acceleration. And for getting this two equation, we didn't included any assumptions. I hope you could understand that. We didn't say that it's a particle, or we didn't stated that kinematics, or no assumption has been included when I am deriving these two equations, okay? Just basic definitions only. Now, from this two equation, that is from the first equation, I can write dt as ds by v. Okay, I am not including the vector sign. The vector signs are introduced just to show that those are vectors, okay? And similarly, second equation, dt will be dv by a. So I can just equate the time component dt and dt. So ds by v will be equal to dv by a, which implies a ds is equal to v into dv. This is a very important equation. This equation is called as time independent equation of motion, okay? Time independent equation of motion. As you could see that it has velocity and acceleration, but it doesn't have any component of what is that, it doesn't have any component of time, okay? So that is why it is called as time independent equation of motion.